Welcome to AirTime with ELGi. This podcast explores the world of air compressors, industry trends, and innovations transforming businesses worldwide. In each episode, we engage with LG Air experts, LG leaders, and LG partners to uncover insights, share experiences, and discuss the future of compressed air solutions. Whether you are in manufacturing, heavy industry, or specialized sector, this show has something for you. I am Prince Lawrence, your host, and today's podcast topic is on energy efficiency in compressed air systems. Now, I would like to welcome Karthik Srinivas, Global Product Manager at LG. Karthik, thank you for joining us. It's great having you on the show. Uh, Karthik, can you introduce yourself a little bit more and share your experience in the compressed air industry?
My name is Karthik Srinivasan. I am part of the Global Product Management Organization at LG Equipments. And I have been in the compressor industry for about 8 years now with LG Equipments. And during this tenure, I have worked with multiple products to understand the customer and the market requirements across these multiple products and have products with best-in-class energy efficiency.
What are the key industries that rely on oil lubricated screw air compressors?
It's quite broad. So when it comes to oil lubricated air compressors, and specifically we are talking about the piston type air compressors or the screw type air compressors, it finds its application in several industries. So be it any manufacturing that you could think of, from automotive to aerospace, from textile to iron and steel, from food industry to general engineering to manufacturing and so on. So any industrial manufacturing process would need compressed air at some stage of the overall manufacturing process. So oil lubricated air compressors find a variety of applications across all these segments. So it's very difficult to list them all. But as you can imagine, any manufacturing that you could think of, except for very specific segments like, let's say, food and beverage and pharma, where the oil-free compressors are being used. Other than that, most of the industries are just fine with the oil lubricated screw air compressors.
How have industries' requirements evolved over the years, and particularly in efficiency and reliability?
I think energy efficiency being the theme of this discussion as well, I think has been a key product driver for compressor manufacturers across the world. Now, as one of the global manufacturers of air compressors, LG's focus is to create products with best-in-class energy efficiency. Now, there are two angles to it. The first one is the reduction of carbon footprint itself. And when it comes to air compressors, 80% or more of the cost that's being spent on an air compressor over its lifetime is on the energy cost. So it's very important to focus on that from a cost angle. And the another perspective is on the environmental angle of it. So from both these perspectives, it's very important that energy efficiency is one of the key drivers for our product. And reliability, of course, is a table stake. I think we can't say the reliability is evolving, but reliability has always been an expectation.
Let's talk about LG's latest trends and technological advancement. How do you see market shifting towards high efficiency and low life cycle cost compressors?
Right. I guess we'll probably start from the market first. So again, when it comes to energy efficiency, we touched upon this. There is a lot of environmental or ESG type initiatives that are being activated globally. So there is a lot of pressure in the industry to adhere to a lot of these environmental standards to meet the best-in-class energy efficiency and so on, while they are trying to reduce the overall energy consumption within a manufacturing plant. So there is a sure direction in terms of where the world is traveling in terms of energy efficiency, and the compressor industry is no exception to that. So when it comes to LG, I guess we are looking at products with the best-in-class energy efficiency, and how we have evolved. Like for example, if we take an air compressor, there are several levers within the system that can contribute to energy efficiency, starting from the electric motor that we use to the air end, or which is, as we call, the heart of the machine, which compresses the air. And there are pipings, and there are coolers and separation tank and so on. Each and every element of the product can contribute to energy efficiency. So at LG, we pay attention to each and every element. Of course, there are some elements that are more critical than the other. For example, the motor and the air end, they contribute a lot to the energy efficiency compared to the other elements. However, all elements put together play a role in terms of improving the energy efficiency. So in line with the market trend, what we are trying to do at LG is also to take a very deep look into each and every element of this and try to optimize this to the best we can, so that we can offer the best in class energy efficiency. So we'll talk about the motor and the air end a little bit in more detail as the conversation goes. But I think at an overall level, there is a lot of alignment in terms of where the industry is trending towards energy efficiency and where the efforts are from compressed air manufacturers, including LG, in creating these best in class energy efficient products.
I mean, LG has introduced the latest EG Super Premium and the Permanent Magnet series. So, what makes them a game changer in the industry?
Yeah, we are quite excited about these two product launches recently. I'll take it one by one. The first one being the LG Super Premium series. We have launched this in the larger machines, say 75 kilowatt and above. And again, the key driver is the energy efficiency here. So how do we do it? We have gone with a more advanced two-stage air end, or what I just mentioned as the heart of the compressor, where the compression happens. We are going to do that in two stages. Now, two-stage as such is not new to the market, but the configuration that we have created and the design optimization that has happened to this two-stage is something that's advanced, so that we are able to get the energy efficiency. And how does a two-stage do that? So in case of a single stage, for example, the compressors are rated in terms of the pressure at which they deliver the compressed air. We talk about either 7 bar, 8 bar, or we talk about 100 psi or 125 psi. So what happens in an air end is the compression. So in a single stage compression, this entire pressure ratio is attained in a single stage. But as two stage, as the name implies, it happens in two stages, by which the pressure ratio in each of the stages is optimized, and thereby making the process more efficient. And for example, in a single stage, the heat of compression would be really high, and the efficiency is also lost because of that. But whereas in a two-stage compression, it happens in two stages, and the pressure ratio being optimized also adds to the energy efficiency, or how we gain the energy efficiency out of it. And it is also, we have IE4 motors with this. As I said, the motor and the air end are the two primary elements that contribute to energy efficiency. So we have gone with the IE4 motors, which are the most efficient in terms of induction motors. So these two elements have been optimized to the extent practical. So we are able to provide the industry leading or the best in class specific power consumption, as we call, which is the measurement for us in terms of energy efficiency. And these products will reduce the total cost of ownership to our customers, be it any segment across the globe. And it also comes with an upgraded controller, what we call as Neuron 4. It is a 7-inch touchscreen controller with advanced features that will also ensure the safety and reliability of the machine. From the previous generation, it comes with more features, thereby improving the reliability as well. Now, moving on to the second product, which we call as the EGPM, or the EG Permanent Magnet Synchronous Motor models. Now, these are variable speed models specifically, and we have launched it up to 45 kilowatt now, and more models are to be launched in the coming months. So essentially, a variable speed machine can alter or can change the amount of compressed air that gets delivered from an air compressor. And as you can imagine, the plants across the globe where they use air compressors, the demand for compressed air, let's take a shift, let's take a day shift or night shift. Throughout a shift, the demand for compressed air is not constant. It's going to change a lot with respect to the number of machines operating in a given shift, number of processes that happen within a manufacturing plant, and so on. So there is a need for varying the flow of compressed air. So we are able to compress only the flow that is needed for the plant and not overdo it. In the sense, in a fixed speed compressor, it has a constant flow of air. There is no varying nature to it. So because of which, it always delivers a specific amount of air irrespective of what the plant needs. But with a VFD, we are able to modulate, and we are able to provide the flow that is actually needed for the plant. So what is the benefit with this is that by producing only the compressed air that's needed for the plant, we optimize on the energy that's being consumed by the compressor. Otherwise, what happens in a compressor without VFD is that it runs on what we call as an unload or an idle mode, where the compressor consumes about 25 to 30% of the input power, whereas it doesn't produce any useful compressed air. So with the variable speed drive or the variable frequency drive, we will be able to get around that problem, and we'll be able to deliver the compressed air that the plant actually needs. Now, coming to the permanent magnet part of it. Now, we talked about IE4, which is the highest efficiency in terms of induction motor. When it comes to the variable speed motors, the global standard is IE5. Now, these numbers are IEC standards, they are electrical motor standards that establish the efficiency levels of each of these motors. So, IE5 is the highest in terms of the energy efficiency. But what we are excited about at LG with respect to the PMs is that we exceed the IE5. So, we have met what we refer to as an anticipated standard of IE7, which means it is about 97% in terms of the motor electrical efficiency. So it's quite exciting and also quite valuable for the customer in terms of the motor efficiency. And not just that, traditionally the variable frequency drive machines were being run by induction motors, which had the handicap of being less efficient in lower speeds. Now we talked about flow being varied in the compressor, and that happens by either slowing down the motor or ramping up the speed of the motor. So the traditional induction motors had the disadvantage of the efficiency being lower in lower speeds than the rated speed of the motor. But with the permanent magnet motor, it maintains the efficiency at a pretty stable level, so that even at the lower speeds, it delivers the efficiency that we are expecting. So with the permanent magnet machine, we have this IE5 plus a permanent magnet motor. We have a direct driven air end that has been optimized for these permanent magnet machines. And not just that, to improve the performance reliability, we have also introduced what we call as the intelligent thermal valve system. So essentially it is how we manage the temperature of the oil. We keep it at a very optimal level, irrespective of what the ambient conditions are, irrespective of what the compressor load and load conditions are, and so on. So it maintains the oil at a very optimal temperature, thereby ensuring the reliability of the machine, because oil is very crucial to maintaining the temperature, as well as it acts as a lubricant to the mechanical parts. So it's very important to maintain the quality of oil. So the intelligent thermal valve system also does that. And added to that, the Neuron 4 intelligent controller that we spoke about for the super premium is also here with the permanent magnet machines. So combining all these things, of course, energy efficiency again is the key driver, and we have seen double-digit improvement in the energy efficiency. Now, for a mature product like compressors, it's not every day that you see a double-digit improvement in the energy efficiency levels. So, for example, in the super premium and the PM machines, we have been able to get energy efficiency savings up to 17% over the previous generation of machines. So, it's pretty significant in terms of what we have been able to do in creating these products, thanks to our engineering R&D team for putting their efforts to make sure that we are able to get the best-in-class energy efficiency and offer the best product to our customers.
So LG's Neuron 4 controller and IoT-enabled Air Alert offers advanced monitoring, correct? So how do they enhance reliability and performance in terms?
Okay, that's a great question. So there are two things to it. One is, as you said, the Neuron 4, and other one is the IoT solution that we have, which we call as Air Alert. Now, talking about Neuron 4, it's our latest generation of controllers that we have launched on all our products now. And it is an upgrade from the previous version, and it comes with a 7-inch display with a touchscreen user interface. And we have tried to add more features to it, more memory to it, which in turn will improve the capability of the machine, such as adding more safety trips to it, adding more, let's say, languages to it, because we are selling compressors across the globe, so there is need for so many languages to be loaded. And in addition to that, it also can take more and more advanced sensors. So it is fully scalable for the future, where more intelligent sensors can be added. For example, the intelligent thermal valve system that we talked about works very well with the Neuron 4, because there is an additional sensor to it, and there are complex algorithms and programs written inside the controller to optimize, let's say in this case, the oil temperature. So it improves the safety and the reliability of the machine. Now, coming to the IoT part of it, which is Air Alert. Now, Air Alert is a device that takes the data from the compressor and it sends it to a cloud. And in the cloud, there are again programs and algorithms that sort and structure the data for certain useful things. Now, Industry 4.0 is a buzzword, right? You see everyone or you hear everyone talking about it, and there is a lot of buzz going around it in terms of Industry 4.0. But I think we still need to be very clear in terms of what value that we are adding with Industry 4.0. So with Air Alert, we are very clear that the fundamental objectives are to improve uptime, which is again the reliability part of it, and to also give us insights that will enable us to improve the energy efficiency. These are the two main I would say objectives for us to have Air Alert. So how does it improve? Now we'll take the uptime piece of it. So traditionally you have a compressor sitting in one corner of a plant. Now even if there is some maintenance coming up, someone will have to go see the controller.
Right.
Of course, it gives you certain warning lights. You can, but it's very manual in terms of how you can track
Correct.
and service the machine. So this is, I'm talking about very simple planned maintenance that you need to do, let's say once in 4,000 hours or 8,000 hours. With Air Alert, now it's getting very smart. Now you have the data. Now this data can be sent through the computer or to your phones, where you can take a look at how many hours are remaining for doing a certain service. So there are service alerts. That's very basic, right? That's coming from the controller. But where the exciting thing is happening in terms of uptime is in the ability to predict failures ahead of time. Now we have progressed in terms of Air Alert detecting some of the failures based on the trends on the parameters. So what it does is it continuously monitors more than 65 to 70 parameters in a compressor. You would probably can think of pressure, temperature, but there is going to be running hours, there is going to be pressure sensor and so on. So there are multiple parameters that gets monitored by the controller. Now that data is fed to the cloud with the help of Air Alert. Now with this algorithms and everything, now it can start looking at how the temperature or the pressure for a given, let's say, ambient condition starts to change. And if it detects, or if it if it monitors any abnormality, then it can give an alert ahead of time saying something is not right here. And of course there are several rules written in the back end, thanks to our experience in compressed industry for a long time and the know-how and the know-why. It gives a lot of data points in terms of what you should be looking at and what are the potential failures that can happen in the future. So the predictive maintenance is an evolving area. So it will continue to evolve. Of course, the ideal state would be to predict all failures if possible, but it's probably some distance away. But we would still be able to predict the critical failures that can happen to a machine by, let's say, a simple example is the machine is more experiencing an abnormal rise in temperature over a period of 48 hours or let's say 96 hours. Then there is an alert that's given to the customer and also the service team that something is not okay with this compressor. So that gives them the opportunity to intervene ahead of time. So once you do that, then you can troubleshoot better and also prevent any catastrophic failure that can happen, and that can result in very costly downtime of the machine. So I think that's where the more exciting part is in terms of how we can improve the predictive ability as we move into the future. And the second piece we talked about is the energy efficiency part. Now again, back to the Neuron data. Now, since it continuously monitors the operating hours and the mode of operation, we talked about load, unload, variable speed. So Air Alert can capture all this data. And what we are essentially looking at is on a month basis, how the compressor is being utilized. Now, every air compressor, especially on non-VFD or fixed speed compressors, has a certain utilization that it needs to operate at so that it can be at its best in terms of energy efficiency. Now with Air Alert, you get this data on a monthly basis or even a daily basis, which if you are interested to see that data, but there is a monthly summarized report that gets sent to the customer. And the customers can take a look at it and then see if it is being utilized optimally. And of course, they can take help from the service personnel and then do a verification if the compressor is operating in a very efficient zone. Or if it is inefficient, there are multiple solutions that are possible. A variable frequency drive is a potential solution. But even a simple tip like, for example, the set pressure, what we call as a load unload pressure, by optimizing them, you can also optimize the load unload or the utilization hours and so on. So there could be multiple insights that would come to the user as well as the manufacturer, with which we can continuously improve the energy efficiency of the machine. So I think Neuron 4, along with the Internet of Things, Industry 4.0 Air Alert, I think it's a big boost to both reliability as well as getting insights on how efficiently the machine is operating, leading into how efficient you can get from there.
Now let's talk about the importance of energy efficiency. So what should industries consider when investing in an energy efficiency air compressor?
Sure. So any industry or a plant, when they are trying to make a decision on what air compressor to choose, of course, the first thing to know would be the what is the application demand, in terms of the duty cycle, how many hours it's going to operate as a plant, and then within the plant, how many of those equipment would need compressed air. So there should be a clear understanding of what is the compressed air flow and at what pressure it is required. So once the basic clarity is obtained, then you try to choose the right type of compressors. Now, as we were talking about, oil lubricated is one type, oil free is another one. So depending on the application, for most industrial applications, we said the oil lubricated compressors are just fine. So once you have the clarity on the duty cycle, the flow that is required in terms of compressed air, and the operating pressure. Now, again, this could be multiple pressure values depending on the machine and the processes and the application. So once those details are arrived at, now is the time to engage with the compressed air manufacturers, or compressor manufacturers can help in evaluating these things as well. So once this is evaluated, then it gets into the step of whether one compressor can satisfy this demand, or is it optimal to use more than one compressor. Now that depends on the nature of the duty cycle, whether all machines in a plant are going to run at the same time, or different machines are going to run in different shifts, or can a variable speed drive or a variable frequency drive address those varying needs. If if one machine with a variable frequency drive is unable to meet that demand, then you would go for more than one machine. The idea would be to go after the compressor with the best in class energy efficiency. Now there are industry standard metrics to measure that. For example, there is specific power consumption, and once you know the flow value of what you need for compressed air, then the next focus must be on what is the specific power consumption. So for a given flow rate, how much energy that's going to be consumed. So the compressed the compressed air system people can help the industry and the customers with this expertise in terms of what is the best configuration that they can achieve. So I think it's probably a few steps in terms of how you can understand what is the plant demand, duty cycle, choose the right technology, and I think another important fact is also to size the compressor properly. Now you would see in many plants that they try to plan for a future that is bit some time away, and try to sort of oversize the compressors. Now again, oversizing a compressor is not a good idea because it will not be energy efficient. So a balance between a future plan and a most optimal compressed air system needs to be discussed, and it needs to be evaluated before making the choice on which type and size of compressor, or more than one compressor is needed or not.
Now let's discuss about what are the challenges and solutions that we can offer to the customer. So how can business balance performance, cost, and sustainability when choosing a compressor?
I think that's a great question. I think that's the optimization game to be played: performance, cost, and sustainability. So when it comes to performance of air compressors, of course, we talked about energy efficiency a lot. That also lends itself to sustainability. We'll come to that. But there are other performance parameters, like for example, for a given size of the machine, let's say typically compressor size is given in, let's say, kilowatt or a horsepower. For a given horsepower or kilowatt, how much flow are we able to offer is one performance parameter. And there are other performance parameters such as let's say noise and the quality of air and so on. So once the decision is being made on the compressors, the plant requirements, and in addition to the other performance requirements as well, in addition to the duty cycle and the compressed air requirement, these are some of the other parameters like quality of air, the noise levels and so on. They need to be identified, and they need to be the compressors need to be rightly selected so that those expectations are also met. And when it comes to cost, I think we would like to focus on the total cost of ownership and just not on the initial cost. So the total cost of ownership, it constitutes of the initial cost, it has the maintenance cost to it, and the biggest part, the energy cost, which we said it's about 80% or above for a typical compressor. So it would be a good decision to go with the total cost of ownership rather than the initial cost, because initial cost and maintenance cost probably are going to constitute about only 20% of the total life cycle cost. So it's important to take a look at the long term, let's say 5 years or 10 years when it comes to life of the compressed air, rather than looking at the initial cost alone or the maintenance cost alone. So the total cost of ownership is a great measure to choose the right compressor. And the third one is sustainability. Now, while energy efficiency itself that we talked about will lend itself to sustainability, the other parameters to sustainability, like using safe materials, using recyclable materials, and safe disposal practices and so on. So the industry is evolving more and more towards this. There are some countries that would not allow some of the materials, there are chemical restrictions and so on. Right. So from a sustainability angle, those parameters are also included. There are several environmental standards that are also kicking in around the world. So compressors have to meet these standards or exceed these standards so that we are able to provide the sustainability features to our customers. So it is a balance, as you rightly put it, because one cannot go with a single dimension of let's say the initial cost or the performance. It has to be a fine balance between the demand that a plant requires and how a compressor is being chosen based on all these parameters.
So now that we are in the end of our podcast session, I would like to ask you one last question. So, as industries adopt smart manufacturing, how do you see air compressors technologies evolving?
Sure. I think we would probably see two aspects of it. One is the management of the compressor room itself, right? So, for example, today, if you take a compressor room, there is an air compressor, and there are going to be accessories always, to ensure the quality of the air. There are dryers, there are going to be filters, and so on. So, the what we are seeing as an evolving area is that the compressor rooms are getting smarter. There is, more and more controllers at a monitoring level that can monitor the entire system in a compressor room, which can continue to optimize the way in which the compressed air system operates, both from a reliability perspective and also from energy efficiency perspective. That's within the compressor room itself, with advanced master controllers, advanced compressor room controllers, and advanced optimizers. When there are more than one or two compressors, how to optimize them. So this is one trend that will happen within the compressed air system room. But outside of that, the compressed air system is plugged to the plant air demands. So what we are looking at now, which is still evolving, is that the machines that use compressed air are also getting smarter and more efficient. So what do we mean by that? For example, in a textile machinery that used to require, let's say 7 bar to operate, it gets lower to about 5 bar or 4 bar. So there is a lot of optimization that happens at the plant machinery end as well. And there is there will be more and more need in the future for compressors to be connected to these plant machinery as well, so that it can adjust itself to what the machine needs at that point in time. Now, the stage we are in today, it is all sort of preset. It is dynamic, but it's not dynamic to an extent that it can get to. So with more advancements in smart manufacturing, if the compressor controller system can talk to several plant machineries, then it can sort of self-optimize itself to ensure that the reliability and the energy efficiency are improved. So that's one trend that we see in terms of smart manufacturing. So as more and more sensors get connected, more and more machinery is getting connected to the compressed air room and so on. But it's very much an evolving area. But that's probably one area that where we could see a lot of innovation happening and technology moving towards.
Thank you, Karthik. Thank you for sharing your insights on energy efficiency in compressor systems.
Thank you, Prince. Thank you for having me. I had a good time sharing my thoughts, and I hope the viewers will take away a little bit of information that will help them in choosing the right compressed air system for their plants. Thank you very much.
As industries evolve, the need for reliable, energy efficient, and intelligent compressed air solutions has never been greater. At ELGi, we are committed to driving innovation, delivering solutions that enhance efficiency, lower operating costs, and support a more sustainable future. From advanced compressed air technology to IoT driven insights and customer centric designs, we empower businesses to make smarter, more energy efficient choices. Thank you for tuning in today. Please stay connected with us for more insights into the future of compressed air solutions. Until next time, here is to a future powered by efficiency, reliability, and innovation. Thank you.